All right, today for our lesson today, we're going to actually start with section 6.2 um, and cover exponents, which is something that you've already studied in Algebra 1. So a lot of the things we talk about today should be reviewed for you, if, not a little bit just to refresh your memory. And I'll try to keep it quick and simple. Chapter 6 starts with exponents, properties of exponents, and then it picks up, the rigor picks up, and you'll start studying properties you haven't learned before. And then we're going to move into what we call logarithms, which are the inverse operations of exponents. Okay, so um, when we're dealing with exponents, that's just repeated multiplication. Similar to multiplication is repeated addition. And this should be very familiar, right? So if you see x cubed, that's really x times x times x. X times itself 3 times, x to the seventh, x times itself 7 times. X to the first is just x. And that's it. We usually try to simplify it as much as possible. Next concept here, this is more about the language than anything. So if you're looking at an expression that is x raised to the exponent of n, okay? This entire thing is called the power. X to the n is the power, and the power is made up of a base and an exponent. X is the base in this case, n is the exponent, and again, the whole thing is the power there. Common powers you should start becoming familiar with. They occur often in a math classroom at our level. So there's a table here that highlights the perfect squares, the perfect cubes, and so on up to x to the sixth. And these are ones that you're going to see often. So it's just to get you familiar with them and start recognizing them. Some of these over here, those are, they're a little more uncommon than the rest over in the upper left corner here. But you'll still see them, and you'll still have a calculator in some cases to deal with these large values. But you want to start kind of making sense of these smaller values or powers, so you can get through some of the problems quicker. And then it just jumps into the next page after number 10 and just takes you to the second power. And these are pretty common as well. Okay, so right now we're just strictly dealing with properties and exponents that you've been exposed to previously in your other math courses. Just positive integers right now, and then we'll move on to negative integers, 0, and then rational integers, fractional integers, or exponents, excuse me. I kept saying integers. So the key thing here is when you have an expression raised to an exponent, and grouping symbols are critical. So in this particular case here, x times y, the whole group raised to the fifth power there, you would raise x to the fifth power and y to the fifth power. These are factors, they're multiplied. So if it's just a monomial, single term, every factor in the group must be raised to the exponent. Whereas this case here, x minus y, this is not a monomial, it's two terms. This exponent 5 does not get distributed to each term here. This is a long process where you take the binomial x minus y and multiply it to itself 5 different times. Over here on the right, this is negative x to the fifth, so then you would raise negative x to the fifth power in that case. And that can be different. So if this was left without a grouping symbol, it has a different meaning to it. So again, over here, xy to the fifth is really this expression here, x times y to the fifth. X minus y to the fifth in this case is the expression x minus and then the group y to the fifth power. Be careful with this one. Negative x to the fifth. This is tricky because the negative x is not grouped. So the way this is understood is this negative out here is more like a 1. A negative 1, excuse me. All right, so that's really like negative 1 times x to the fifth, and then it kind of expresses itself right here. So this is this area here you got to be really careful with, and then this one right here. Just knowing that you cannot distribute an exponent to multiple terms in a group. You have to go through this long process there. So some examples, evaluate each expression. So we are not simplifying, we're evaluating. We're working with these operations here, and a lot of it is order of operations, and you just got to keep remembering, stick with order of operations. So we just kind of discussed this over here. This expression here is really -1 times 3 squared, and then that's -1 here times 9, which is going to become -9. Now the -3 is grouped and squared, so we're just going to square -3, and then we have a +9. Here to the left, again, order of operations runs everything. We must square 3 first. Exponents comes before multiplication here. So this is really 2 times 9, which is then 18. In this particular case, you could look at this two ways, but the order of operations would say to multiply 2 times 3 first. That's what's in the group. So this can be completed by looking at it as a 6 to the second power here, which is 36. However, other people might look at this a little differently and take each of these factors here, 2 and 3, and raise each factor to the second power, leaving you with 2 squared times 3 squared, or 4 times 9, leaving you with the same value, 36. The blue process here is probably the quicker, better process in this particular case. However, sometimes you're going to have variables here in the base, and you have no other choice but to raise each factor individually. On the left, or excuse me, down below at E, order of operations runs this as well. 2 plus 3 here is 5, so this is really 5 squared, which is then 25. Okay. Again, you cannot distribute here, so this example down below, this does not exist. 2 squared plus 3 squared here doesn't play out correctly because that's 4 plus 9, which is 13, which is not 25 here. So this process does not work. Just keep that in mind. And then we have, more evaluating with a different example. Again, order of operations is going to run all of this. So first example here, 3 minus 7 squared. Again, we cannot distribute this exponent of 2 to both of these terms. So what you're going to do is you're going to run with the order of operations. 3 minus 7 is -4, and then that is squared. -4 squared is +16. On letter B here, we have 3 minus, and then 7 squared is 49. So we have 3 minus 49 giving us -46 here. Lastly, we're going to have 3 and then plus, and then that -7 squared becomes a +49. 3 plus 49 here is 52. And that's going to take us to the end of the lesson here, right? So you have a short assignment to work on, and then we'll come back when we return to school and pick up the rest of this lesson. We're covering, this lesson originally was scheduled to cover 3 sections, 6-1, 2, and 3, mainly because it's a lot of Algebra 1. And I'll be available on Google Meet if you need to meet with me on Thursday during the school day.